Question 5, on paper 2, a bank issues a unique 4-digit PIN code to customers and they want them to use that for their debit or credit cards. The code is chosen at random from digits that can be from 0 to 9 inclusive. So that's 10 digits because you've 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. So that's 10. A code cannot begin with 0, but digits may be repeated. For example, 1995 is a valid code. Find the number of possible 4-digit PIN codes in which no digit is repeated. Okay, so they want me to find the number of 4-digit PIN codes where no digit is repeated as a percentage of the total number of possible codes. Give your answer correct to 1 decimal place. Okay, they're asking a couple of things in one question there. So how do I get a percentage? I need a fraction and I multiply it by 100. What's my fraction? What's my top and the bottom of my fraction? The top of my fraction is the number of codes where no digit is repeated. And the bottom of my fraction is the number of possible codes, whether they're repeated or not, who cares? So the way I kind of wrote that just to start off with is, hopefully this might get me my attempt marks even, just to show them I know how to create a fraction and a percentage. The number with no repeats on the top and the total possible on the bottom. So I'm going to go straight away to the total possible ones. It has the least number of restrictions in it. You could start doing out a sample space. You could have 1 1 1 1, you could have 1 1 1 2, 1 1 1 3, etc. So you could have that full list. You could have 1 2 1 1 1 2, 1 2, etc. And what you eventually see is that you just have options. Just pick your options. I'm going to go to the place that's restricted first, and that's the first one. You cannot have a code beginning with 0. So you have 9 options here out of the 10, because you could have the number 1 there, 2 there, 3 there, 4 there, 5 there, 6 or 7, 8, 9, 10, or 8, 9. So I've 9 options there, and you can imagine the very first digit in your sample space would be, a load with the number 1, a load with the number 2, a load of them with the number 3, etc. So you're imagining here so that we don't have to do out the sample space, which would not be possible in the time given. Then one of those digits will be picked, and we actually have 9 other options then, because 0 comes into play as an option for the second digit. Or do we have 10? Because we can repeat, so we have 10. Because we can repeat, it doesn't matter which one of the 9 was used, but we can have 10 for the second one. And that means that we could have 10 for the third one. I'm allowed repeat. So that's 9 by 10 by 10 by 10. So we have 9,000 as the bottom. And then as the top, now we can have no repeats and we can have no zeros. So now this is going to be more looking like the one that I accidentally started off doing. So 9 is there. One of those is picked and we can't repeat, but 0 comes into play. Then 2 have been used. So now we're on 8 and then 7. Throw that into the calculator. And we have 4, 5, 3, 6. So that's 4, 5, 3, 6 on the top, 9,000 on the bottom. Throw that into the calculator, multiply by 100, and you round off to 1 decimal place. Next question. A PIN code in which no digit is repeated is issued to a customer. How many different PIN codes, which are even numbers? So now we have 2 things that we need to take into account. And then greater than 3,000 are possible. So even and different. Okay, so if we go for pin code, so greater than 3,000 and is an even, means, so greater than 2,000 means that it starts with 3, 4, 5, 6, 7, 8, 9. That even means ends with 0, 2, 4, 6, 8. Okay. So now we're going to have to do two options here, I think. Because if it starts with an odd, then... Okay, so let's do this. I'm going to just separate them out. Okay. And I have to do this because if we look here, if I start with an odd, so we have 1, 2, 3, 4 options, let's say, but that doesn't impact our ending on an even. Whereas if we start on an even, that does impact that I've ended on an even. I'll be down 1 because I'm not allowed to repeat. So I do have to split this out into 2 different ones. So starts with an odd. 1, 2, 3, 4. We have 4 possible. Then the next thing is that the next one can be any number, except it has to be different from the first one. So that's a 9. No, hold on. No, yeah, sorry. I'm actually going to go straight to the other restriction first. So I'm going to go, generally with these, you go to the most restricted places first. So if I start with an odd, then and end with an even, 1, 2, 3, 4, I have 5 options there. So now I have 2 numbers used, so I'm on 8 in here. And then 7. Which gives me, if I start with an even, so now these are my starting ones, and it has to be greater than 2,000. So that's 1, 2, 3. And I finish on an even. Now that means I've already used one of those, which means that I'm now down to 4 options there. And then I've used 2, so then 8 there and 7 there. Multiply all that out. And 1792 is the total. When you add your 2 numbers together, that's 672. So hopefully that makes sense there. So when I worked that out, I got 672, and when I added those 2 together, I got this. So that's the different pin codes, which are even numbers greater than 3,000, and they're all different digits in them. Now we're on to a bit of probability. Find the probability that all the digits in the pin code issued are in ascending order. Okay, so they've given me a couple of examples there, but if you need more, do out your sample space, etc., so that you can give yourself an idea of what the issues are. So find the probability that all digits are in ascending order. That means that you cannot, again, begin with 0. So you cannot begin with 0. You have, well, maybe just to even be sure that I have my marks here, probability is desirable outcomes, or whatever way. outcomes over total possible outcomes. I think from the very first part I have my total possible outcomes. Now I'm back here, part B, just making sure this is all linked. A PIN code in which no digit is repeated. Okay, so I need to, if there's no repeats, I have that done in part 1, and that's 4, 5, 3, 6. Okay, so on the bottom here, 4, 5, 3, 6. Even just, I don't know if that'll get me a 10 marks, but just I'm writing it in anyway. So if we're going to go in ascending order, 0 cannot be first, so we have 9 options. Okay, do we have 9 options? No, we don't. Like 0 cannot be there, but neither can the number 9, because you can't have 9, 9, 9, 9. You can't have repeats. Can 8 be there? No, because you can't have 8, 9, whatever. So can 7 be there? No. Can 6 be there? 6, 7, 8, 9. Yeah, it can. So 6, 7, 8, 9. Now maybe we want to do this out, because that doesn't sound like the worst here to work on. So 0 cannot be first there. Alright, so if the number 1 is first here, so if this is the number 1, then what can we have after that? You can have, it would be easier to do this by choosing. Because if you think about it, we don't want all possible permutations. We want so let's just even think, like, let's just say it was 2 digits. We want 3, 4. We don't want 4, 3. So choosing gets rid of the 4, 3 option. It halves your options, let's say, or in this situation, you know, it's not halving that we're doing. But I actually think that perhaps choosing might be the way to go, because it seems as though there's way too many, unless I actually do out my sample space, which I don't have time for. It looks like I might just have to work with choosing, and I think that actually is a pretty nice, straightforward way. So this is just me having, like, looking at my probability question, and this is genuinely how I'll look at them. You know, I'll look at my sample space, I'll look at my options, doing it with the boxes. But if I can't do that, you know, you get pushed into the next thing and into the next thing. So I think there's a flaw here if I try and do the boxes. It'll be too complicated. So what do I have? I have 9 outcomes, because I can't have 0, let's say, as my first one. And I want to choose 4. So will this work for me? So occurs cannot begin with 0. So you've eliminated, so we've completely eliminated 0. 0 can't be an option at all, because if we can't begin with it, then it can't be anywhere else. So it is, yeah, we're looking at 9, choose 4. Throw that into the calculator. And we have 1, 2, 6. So that's my top. And what do they want me to do? They don't care, so I'm going to write it as a fraction, because if I write it as a decimal, it probably won't be as accurate. So 1 out of 36 is my answer there. Okay, that was interesting as to, you know, the total possible on the bottom. I'd already done in part A, and then this was got kind of pushed into choosing there to do that one. 6 students compare the months in which they celebrate their birthdays. Okay, assuming that all months are equally likely, find the probability that no 2 students were born in the same month. So if they were all... Okay, so that means that no 2 were born in the same month, means they were all born in different months. So we have 6 students. So that means the first one was born in whatever month, and the next one was born in a different month to the first, and the next was born in a different month to the first 2. And okay, so I'm lengthening out the sentence here. So this is probability again. So what are the chances the first person was born on any month? 12 out of 12. And the next person was born in a different month. So if I was born in January, then the next person just has to be born in a different month to me. So that's 11 out of 12. If we were born, let's say, so the first person, I was born January and the next person was born February, that means the next person just has to be born in a different month. So that gives them 10 out of 12. And okay, so this looks pretty straightforward. 9 out of 12. And how many of us is there? 8 out of 12. 6 of us. Yeah, 6. And 7 out of 12. Which, throw it into the calculator. And I end up with 0.22280 blah blah. I have to give my answer correction 4 decimal places, so there it is, 0.2228.